Hello everyone, Dennis here. In this video, we are going to discuss about GC O-Level Additional Mathematics October-November 2018, Paper 2. The subject code is 4047. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out free lessons from me. Question 1. The quadratic equation x squared plus 3x plus 5 equals 0 has roots alpha and beta. 1. Show that alpha plus 1 times beta plus 1 equals 3. 3 marks. 2. Find a quadratic equation whose roots are 2 over alpha plus 1 and 2 over beta plus 1. 4 marks. And here's the solution. For part 1, given the equation x squared plus 3x plus 5 equals 0, so first we need to identify the value of a, which is 1, b, which is 3, and c, which is 5. So first we want to find sum of roots, which is alpha plus beta equals negative b over a, and the value is negative 3. Then we find the product of roots, which is alpha times beta equals c over a, and the value is 5. Hence, alpha plus 1 times beta plus 1 equals alpha beta plus beta plus 1. So alpha times beta we know is 5, alpha plus beta is negative 3 and plus 1, and the value will be 3. Hence shown. Part 2. First, we need to find the sum of new roots, which is 2 over alpha plus 1 plus 2 over beta plus 1. Then we combine them together, we get 2 times beta plus 1 plus 2 times alpha plus 1 over alpha plus 1 times beta plus 1. We expand the bracket, we get 2 beta plus 2 alpha plus 2 over alpha plus 1 beta plus 1. We can simplify, we get 2 times alpha plus beta plus 4 over alpha plus 1 times beta plus 1. Then we can start to substitute the value. We know alpha plus 1 is negative 3. At the bottom, alpha plus 1 times beta plus 1 is 3. Hence, it will be 2 times negative 3 plus 4 over 3. And the value is negative 2 over 3. Next, we find the product of the new roots, which is 2 over alpha plus 1 times 2 over beta plus 1. And we can write it as 4 over alpha plus 1 times beta plus 1. And the value is 4 over 3. Therefore, the new equation will become x squared minus the sum of new roots x plus the product of new roots equals to 0, which becomes x squared minus negative 2 over 3x plus 4 over 3 equal to 0. And we can rewrite it as 3x squared plus 2x plus 4 equals to 0. Question 2. The first three terms in the expansion of 1 minus 4x times 2 plus ax to the power of 6 in ascending powers of x are 64 minus 160x plus bx squared. Find the value of each of the constants a and b. 7 marks. Here's the solution. First, it is given that 1 minus 4x times 2 plus ax to the power of 6 equals 64 minus 160x plus bx squared plus so on. So first we apply the binomial theorem formula. For the bracket 2 plus ax to the power of 6, we get 1 minus 4x times 2 to the power of 6 plus 6 choose 1, 2 to the power of 5, ax plus 6 choose 2 times 2 to the power of 4 times ax squared plus dot dot dot, okay, equals 64 minus 160x plus bx squared plus dot dot dot. Simplifying, we get 1 minus 4x times 64 plus 192ax plus 240 a squared x squared plus dot 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 equals 64 minus 160 x plus bx squared plus dot dot dot. And now we want to find the values of a and b. So first we compare the coefficient of x, and from the left hand side 1 times 192ax will give us the x term. Hence, it will be 192a for the coefficient of x, followed by negative 4x times 64 will also give us the x term. Hence, we can plus with negative 4 times 64. Then, the right side, the x term is negative 160x. Therefore, it is equals to negative 160. Then we solve this equation. We get the a will be half. Next, we compare the coefficient of x squared to find the value of b. So from here, 1 times 240 a squared, x squared will give us the x squared term. Therefore, the coefficient will be 240 a squared. Followed by 4x, negative 4x times 192ax will give us the x squared terms as well. Therefore, it will be plus negative 4 times 192a and equals to the right hand side b. We know that a is half, then we substitute the a into this equation. We get 240 times half square plus negative 4 times 192 times half equals to b. Calculate this equation, we get b equals to negative 324. And this is the answer. Question 3. Given this diagram. In the given diagram, a line from a point A intersects a circle at the points B and C. The line AP is a tangent to the circle at point B. The point Q lies on AC such that AP equals AQ. Prove that PQ bisects angle BPC. 5 marks. Here's a solution. Given that AP equals AQ, which is this line, equals to this line. Therefore, triangle APQ is an isosceles triangle. Hence, we can say that angle APQ equals angle AQP. So, which is this angle and this angle. And we know that angle APQ equals angle APB plus angle BPQ from the diagram, which means this angle plus if this angle will give us angle APQ. So the equation becomes angle APB plus angle BPQ equals angle AQP. Next, angle AQP is also equal angle QCP plus QPC, which is this angle and this angle, because it is exterior angle equals sum of interior angle. Hence, we equate the equations which we get angle APB plus angle BPQ equals angle QCP plus angle QPC. From the diagram, we also can say that angle APB equals angle QCP, which is this diagram, this angle equals to this angle, because it is alternate segment theorem. Hence, angle APB plus angle BPQ equals angle APB plus angle QPC. Then we can cancel the angle APB, we get angle BPQ equals angle QPC. Therefore, PQ bisects angle BPC and shown. Question 4 is a linear law graph question. Here's the question. Recorded values of the mass m grams of a radioactive substance T hours after observations begin are shown in the table below. And here's the table. It is known that m and T are related by the equation m equals MOE to the power of negative KT, where MO and K are constants. 1. Plot ln m against T and draw a straight line graph. 3 marks. Use a graph to estimate 2. The mass of the substance when the observations begin, 2 marks. 3. The value of K, 2 marks. 4. The time taken for the substance to lose half of its original mass, 2 marks. Here is the solution for part 1, which is plot ln m against t and draw a straight line graph, 3 marks. So the first thing we need to do is we have to calculate ln m for each of the values of m. So the first one, the m is 36.4, so ln 36.4 we get 3.60. Next value, m is 22.1, so ln 22.1 will give us 3.10. The next number, 13.4, so ln 13.4 will give us 2.60. And the last number, 8.1, so ln 8.1 will give us 2.10. Then we can start to plot a graph. So this is a A4 size graph paper. So first we draw the x-axis, which is in terms of t, and the y-axis, which is ln m. Then we can label this x-axis, which is 2 cm to 20 units. So 20, 40, 60, and 80. For the y-axis, which is ln m, so we can take 2 units as 2 cm as 1 unit. So this 1, 2, 3, and 4. Now we can start to plot a graph. The first point is 20 to 3.6. So this is the first point, followed by the next point, which is 40 and 3.10. The next point is 60 and 2.60. So this is a point. And the next point is 80 and 2.10. So this is a point. Then the next thing we do is just connect these points with a straight line. Right, now the next one, here is the solution for part 2, which is the mass of the substance when the observation begin. So when the observations begin, the t equals to 0. So this is the point that we can look for. From the graph, ln m equals 4.15. Hence, m equals e to the power of 4.15, and the value is 63.4 grams, rounded off to 3 significant figures. And here's the solution for part 3. Use a graph to estimate the value of k, 2 marks. So given the equation is m equals MOE to the power of negative kt, we ln both sides. We get ln m equals ln MOE to the power of negative kt. And next we apply the logarithm laws. We get ln m equals negative kt plus ln mo. So the gradient will be, first we need to find 2 points which we can easily read the coordinates. So we choose these 2 points and we can apply the formula, the gradient, which is 2.10 minus 3.60 over 80 minus 20. And the value is negative 0.025. This value equals with the equation negative k, therefore k will be 0.025. Here is the solution for part 4. Use a graph to estimate the time taken for the substance to lose half of its original mass. So when the mass is half of the MO, which is half times 63.4, the value is 31.7. Then we ln the m, we get ln 31.7, the value is 3.46. From the graph, here is 3.46, and the corresponding t value will be this point. So from the graph, the t equals 26. Therefore, the substance takes 26 hours to lose half of its original mass. Question 5. Given this diagram, the diagram represents the path of a skier. He takes the ski lift from A to B, a journey of 800 meters along a slope inclined at theta degrees to the horizontal. From B, he skis 1,200 meters downhill to finally reach point D after passing through the point C. The points E, C, and A are the same level, and E is 200 meters directly above D. 1. Given that angle ABC is 90 degrees, express BC in terms of tangent theta and hence obtain an expression for CD. 2 marks. 2. Hence, show that DE can be expressed in the form A cosine theta plus B sine theta, where A and B are constants. 3 marks. 3. By expressing DE in the form R cosine theta plus alpha, find the value of theta. 5 marks. Here is the solution. 1. So from the diagram, tangent theta equals BC over 800, which is from the triangle ABC. So BC equals 800 tangent theta. Therefore, CD will be 1200 minus BC, which is 1200 minus 800 tangent theta. 2. Angle DCE equals angle ACB because it is vertically opposite angle, which is equals 90 degrees minus theta based on the triangle ABC, so angle sum of triangle ABC. Sine angle DCE equals DE over CE. So this one is based on triangle CDE. Then from here, DE equals CD sine angle DCE. They will substitute CD with 1200 minus 800 tangent theta from the equation of part 1. So DE will be 1200 minus 800 tangent theta times sine 90 degrees minus theta. And we know that sine 900 minus degree minus theta is cosine theta, tangent theta is sine theta over cosine theta. Then DE will be 1200 minus 800 times sine theta over cosine theta times cosine theta. Then we expand the bracket, we get 1200 cosine theta minus 800 sine theta, hence shown. Part 3. DE equals 1200 cosine theta minus 800 sine theta. So from here, we want to convert this equation into R formula. So we find the value of R, which is square root of 1200 square plus 800 square, and the value is 1442.22. Alpha will be inverse of tangent 800 divided by 1200. So the alpha will be 33.7 degrees. So all these we are applying the R formula. Hence we can rewrite the length of DE equals 1442.22 cosine theta plus 33.7 degrees. From the diagram, DE is 200. Therefore, we equate the equation 1442.22 cosine theta plus 33.7 degrees equals 200. Now we can start to solve this equation. Cosine theta plus 33.7 degrees equals 200 over 1442.22. So the angle theta plus 33.7 degrees equals inverse of cosine 200 over 1442.22, which gives us 82 degrees. Hence the theta will be 82.0 degrees minus 33.7 degrees, and the value of theta is 48.3 degrees and in 1 decimal place. Question 6. 1. Differentiate x cosine x with respect to x. 2 marks. 2. Hence, find integration of x sine x dx. 2 marks. 3. Differentiate x squared sine x with respect to x and hence use the result found in part 2. Find integration of x squared cosine x dx. 6 marks. Here is the solution. For part 1, we apply product rule. So differentiation of x cosine x in terms of x will be equals cosine x plus x times negative sine x. Simplify, we get cosine x minus x sine x. 2. We start with differentiation of x cosine x over x equals cosine x minus x sine x. Then we make x sine x the subject. We get x sine x equals cosine x minus d over dx cosine x cosine x. Next, we integrate both sides, which we get integration of x sine x dx equals integration of cosine x dx minus integration of d over dx x cosine x dx. And we get integration of x sine x dx equals sine x minus x cosine x plus c. Part 3. Using product rule, d over dx x squared sine x will be equals 2x sine x plus x squared cosine x. Then we make x squared cosine x the subject, which we get x squared cosine x equals d over dx x squared sine x minus 2x sine x, followed by integration of both sides. So we get integration of x squared cosine x dx equals integration of d over dx x squared sine x dx minus 2 integration of x sine x dx. And we get the answer is x squared sine x minus 2 bracket sine x minus x cosine x plus c. Expand the bracket, we get x squared sine x minus 2 sine x plus 2x cosine x plus c. Question 7. A girl cycles up a hill and passes a fixed point A. The distance, d meters, that she cycles in t seconds after she passes A is given by d equals to 840 times 1 minus e to the power of negative t over 80 minus 2t for t greater than or equals to 0. 1. Find the girl's speed and acceleration 10 seconds after she passes A. 6 marks. 2. Explain what the sign of the acceleration indicates. 1 mark. When she reaches point B, her speed is 1.5 meter per second and she gets off her bicycle. Given that A is 500 meters from the top of the hill. Part 3. Calculate the distance she has to push her bicycle to reach the top of the hill. 4 marks. So here's the solution for part 1. Given the equation of the distance traveled by the girl is 840 times 1 minus e to the power of negative t over 80 minus 2t. We can expand the bracket, which we get 840 minus 840 e to the power of negative t over 80 minus 2t. Then, to get the equation of the speed, we differentiate the distance. So with d over dt, 840 minus 840 e to the power of negative t over 80 minus 2t. So we will get negative 840 e to the power of negative t over 80 times negative 1 over 80 minus 2. Simplify, we get the equation of speed v equals 21 over 2 e to the power of negative t over 80 minus 2. To get the acceleration, we will differentiate the equation of the speed, which is d over dt 21 over 2 e to the power of negative t over 80 minus 2. We get 21 over 2 e to the power of negative t over 80 times negative 1 over 80. Simplify, we get the equation of the acceleration, which is negative 21 over 160 times e to the power of negative t over 80. When t equals to 10 seconds, Then we substitute t equals to 10 into the equation of speed, which is p equals to 21 over 2 times e to the power of negative 10 over 80 minus 2, and the answer for the speed is 7.27 meters per second. And for the acceleration, it is negative 21 over 160 times e to the power of negative 10 over 80. And the value is negative 0.116 meters per second square. Part 2. The sign of the acceleration indicates that the girl decelerates as she climbs up the hill. The solution for part 3, given that the speed is 1.5. Hence, we substitute this value into the equation of the speed, which we get 21 over 2 e to the power of negative t over 80 minus 2 equals to 1.5. Then we solve this equation to get the time when he reaches this speed. So it will be e to the power of negative t over 80 equals bracket 1.5 plus 2 times 2 over 21. So e to the power of negative t over 80 equals 1/3. We ln both sides, we get negative t over 80 equals ln 1 over 3. So negative t will be 80 ln 1 over 3, and t is 87.89 seconds. So the next thing we can do is we calculate the distance traveled, which is 840 times 1 minus e to the power of negative 87.89 over 80 minus 2 times 87.89. The value will be 384.22 meters. So this is the distance that she has traveled. So we want to calculate the distance that she needs to push the bicycle. So the total distance is 500 meters. Then will be 500 meters minus 384.22, and it is 116 meters. Rounded off to 3 significant figures. Question 8. The equation of a polynomial is given by px equals 2x cubed plus 5x squared minus 18. 1. Find the remainder when px is divided by x plus 2. 2 marks. 2. Show that the equation 2x minus 3 is a factor of px. 2 marks. And 3. Show the equation px equal to 0 has only one real root. 4 marks. 4. Use your answer in part 2 and 3 to solve the equation e 2 to the power 3y plus 1 plus 5 times 2 to the power 2y equals 18. 3 marks. Here's the solution. For part 1, first we let x plus 2 equals 0, hence x equals negative 2. By remainder theorem, remainder will be equals p to negative 2. So we substitute x equals to negative 2 into the equation of px. Then we get 2 times negative 2 cubed plus 5 times negative 2 squared minus 18. And the result is negative 14. So this is the remainder when the px is divided by x plus 2. For part 2, we let 2x minus 3 equal to 0. Hence x is 3 over 2. So by now we substitute x equals to 3 over 2 into the px. We get p 3 over 2 equals 2 times 3 over 2 cubed plus 5 times 3 over 2 square minus 18. The value is 0. So since p 3 over 2 equals 0, by factor theorem, 2x minus 3 is a factor of px, hence shown. Part 3. To show that the equation px equals to 0 has only one real root, so we have to find the quadratic factor first. As we already know, x plus 2 is the linear factor of the px. So there are two ways we can do to find the quadratic factor. Either we use synthetic method or we use long division. So for here, I will show you the synthetic method. So first we draw this line, then we copy down the coefficients of px. So the coefficient of x cubed will be 2, coefficient of x squared is 5, coefficient of x is 0, as in this equation we don't see the x term, and the constant term is negative 18. So here is 3 over 2, then we copy down the 2 here. Next, 3 over 2 times 2, we get 3. Then 5 plus 3, we get 8. Next, 3 over 2 times 8, we get 12. Then 0 plus 12, we get 12. Next, 3 over 2 times 12, we get 18. Then negative 18 plus 18, we get 0. So this value must be 0, so that there is no remainder. Hence, px equal to 0, right? Which means that 2x cubed plus 5x squared minus 18 equal to 0. We can write it as 2x minus 3 times 2x squared plus 8x plus 12 equals 0. So we divide by 2 for both sides. We get 2x minus 3 times x squared plus 4x plus 6 equal to 0. From the quadratic factor, which is x squared plus 4x plus 6, we can calculate the determinant, which is b squared minus 4ac. And for this case, the a is 1, the b is 4, the c is 6. Hence, b squared minus 4ac will be 4 squared minus 4 times 1 times 6. And the value of b squared minus 4ac is a negative value, which is less than 0. This shows that there is no real roots. Therefore, the equation px equal to 0 has only one real root. Hence shown. Now, here's the solution for part 4. From the equation given, 2 to the power of 3y plus 1 plus 5 times 2 to the power of 2y equals 18. We can rearrange this equation, which we get 2 times 2 to the power of y cubed plus 5 times 2 to the power of y squared minus 18 equals to 0. Right? So we need to rearrange it to this form, so that when we let x equals to 2 to the power of y, the equation can be rewritten as 2x cubed plus 5x squared minus 18 equal to 0, which is the same equation as px. So we can immediately factorize this equation, which is 2x minus 3 times x squared plus 4x plus 6 equal to 0. So 2x minus 3 equal to 0, or x squared plus 4x plus 6 equal to 0. X equal to 3 over 2, and the next answer, right, we don't have any solution. So now we only focus on the first solution. We substitute back the x to be 2 to the power y equals to 3 over 2. Then we log both sides, which we get log 2 to the power y equals to log 3 over 2. We can bring the y to the front, then we get y log 2 equals log 3 over 2. So y will be log 3 over 2 over log 2. And the answer for y will be 0.585 rounded up to 3 SF. Question 9. The equation of a curve is y equals 2x squared plus bracket k plus 2x plus k, where k is a constant. 1. In the case where k equals 5, show that the line y equals 19x minus 13 is a tangent to the curve and find the coordinates of the point of contact. 3 marks. 2. Explain why there is only one value of k for which y cannot be negative and state this value. 4 marks. So here's the solution for part 1. When k equals to 5, the equation becomes y equals 2x squared plus 5 plus 2x plus 5, which is y equals to 2x squared plus 7x plus 5. We name this equation as equation 1. Given the equation of the line is y equals to 19x minus 13, this is equation number 2. So since they touch each other at the point of the tangent. So we can equate equation 1 with equation 2, which we get 2x squared plus 7x plus 5 equals 19x minus 13. So we move everything to left hand side, we get 2x squared minus 12x plus 18 equals 0. So we can simplify this equation by dividing 2 for both sides. We get x squared minus 6x plus 9 equal to 0. Then we identify the value of a will be 1, b is negative 6, and c is 9. Next, we calculate the determinant b squared minus 4ac, which is negative 6 squared minus 4 times 1 times 9, and we get 0. So when b squared minus 4ac equal to 0, this shows that y equals 19x minus 13 is a tangent to the curve, hence shown. 2. From the equation given, y equals to 2x squared plus k plus 2x plus k, the a is 2, the b is k plus 2, and the c is k. Y cannot be negative as stated in the question, hence y must be greater or equals to 0, which means that the b squared minus 4ac must be less than or equals to 0. They will substitute the value b as k plus 2, right? A is 2, c is k, so it will be k plus 2 squared minus 4 times 2 times k less than or equals to 0. We expand the bracket, we get k squared plus 4k plus 4 minus 8k less than or equal to 0. So k squared minus 4k plus 4 is less than 0 or equals to 0. Factorize, we get k minus 2 squared less than or equals to 0. So since k minus 2 squared is a squared number, there is only one possible value for k minus 2 squared, which is equals to 0. So the k can be only be equals to 2. Question 10. Given this diagram, the diagram shows part of the curve y equals 2 square root of 7 minus 3x passing through the point P, k 2 square root of 7 minus 3k, where k is a constant and k is less than 7 over 3. The curve meets the x-axis at the point x. The tangent and normal to the curve at P meets the x-axis at the point T, and n coordinates is negative 5, 0 respectively. 1. Prove that k is equals to 1. 5 marks. 2. Show that the x-coordinate of t is 11 over 3. 2 marks. The curve meets the x-axis at the point x 7 over 3, 0. 3. Find the area of the shaded region pxt. 5 marks. Here is the solution. For part 1, given the equation y is 2 times square root of 7 minus 3x, we can rewrite this equation as y equals 2 times 7 minus 3x to the power of half. Now we differentiate this equation, which is dy dx equals 2 times half times 7 minus 3x to the power of negative 1 over 2 times negative 3. We simplify this equation, we get negative 3 over 7 minus 3x to the power of half. So at point P, the x is equals to k. Therefore, dy dx will be equals to negative 3 over square root of 7 minus 3k. And the gradient of the normal at P, right, we can find by applying the equation of the formula of the gradient, which is y2 minus y1 over x2 minus x1, and we choose point P and N to calculate the gradient of the normal at P. So the gradient will be 2 times square root of 7 minus 3 k minus 0 over k minus negative 5. So we simplify, we get 2 square root of 7 minus 3k over k plus 5. So we know that if you multiply the gradient of the tangent with the gradient of normal, we get a negative 1. So for this case, we get negative 3 over square root of 7 minus 3k times 2 square root of 7 minus 3k over k plus 5 equals to negative 1. So square root of 7 minus 3k cancel with square root of minus 3k. We get negative 6 over k plus 5 equals to negative 1. Then we can solve this equation, which we get k plus 5 equal to 6 and k equals to 1. Hence, proven. Solution for part 2. When k equals 1, the coordinates of P will be 1, 4. So the gradient at P, right, just by substituting the value of x equals to 1 inside dy over dx, we get negative 3 over square root of 7 minus 3 times 1. And the dy over dx equals to negative 3 over 2, which means this is the gradient of the tangent. So let the coordinates of t as a, 0, as the coordinate of t, the point t lies on the x-axis. Therefore, the gradient of pt will be 4 minus 0 over 1 minus 8 by applying the formula of the gradient. So we also know that the gradient of pt will be negative 3 over 2. Hence, negative 3 over 2 equals to 4 over 1 minus 8. Then we solve this equation. So 3 over 2 equals 4 over a minus 1, because I want to remove the negative sign. And I cross multiply, I get 3a minus 3 equals 8. Solve this equation, a equals 11 over 3. Therefore, the x-coordinate of point T is 11 over 3, shown. So the solution for part 3, to find the area of the shaded region, PXT. So firstly, right, look at the diagram. We need to find the area of the triangle here and then minus the area under the curve. So firstly, what I need to do is we update the coordinates of P, as we already known in the previous question, right? So the coordinates of P will be 1, 4. Then I draw a vertical line here, right, touching point P and the x-axis, and it is perpendicular to the x-axis. And at this point, I label it as point Q. The coordinates of point Q will be 1, 0. So we can see that from here, the triangle PQT is a right angle triangle. Okay, so I think you can see, right, to find the area of this shaded region will be the area of the triangle minus the area of this part, which is the area under the curve from Q to X. So firstly, let's find the A1, right, which is the area under the curve here, right, and bounded 1 to 7 over 3, because the x coordinate, right, for x is 7 over 3. So integration from 1 to 7 over 3, 2 times 7 minus 3x to the power of half dx. This is the equation of the curve here, right? So we integrate the equation, we get 7 minus 3x to the power of 3 over 2 over 3 over 2 times negative 3. So I take out the 2 here so that it won't impact the calculation inside the bracket here. So integration from 1 to 7 over 3. Okay, now simplify this area, we get negative 4 over 9 bracket. So 7 minus 3x to the power of 3 over 2. The range is from 1 to 7 over 3. So calculate the value, right, by substituting 7 over 3 inside and then minus substituting 1 inside. So this is what we get, negative 4 over 9 bracket 7 minus 3 times 7 over 3, then to the power of 3 over 2 minus 7 minus 3 times 1 to the power of 3 over 2. Okay, notice that the first bracket I will get a 0. Hence, the value inside this big bracket will be negative 4 over 9 times negative 8. And we'll get the value is 32 over 9 units square. Next, we move on to find the area of the triangle here, triangle PQT, which is I label it as A2. So it is half times the base, right, which is 11 over 3 minus 1, and times the height, 4. Okay, the height here is 4. This is the length. Okay, to just get the x coordinate of T minus the x coordinate of Q. Okay, and the value we get 16/3. Hence, the area of the shaded region will be just A2 minus A1, which is 16/3 minus 32/9, and the answer is 1 and 7/9 units square. Question 11. 3 points are given by A 1 4, B 9 8, and C 7 12. 1. Show that angle ABC is 90 degrees. 3 marks. 2. Explain why A, B, and C lie on a circle with diameter AC. 1 mark. 3. Find the equation of the circle. 3 marks. 4. Explain why the tangent to the circle at B is parallel to the y-axis. 2 marks. And 5. Find the equation of the tangent to the circle at C. 2 marks. Here's the solution. For part 1, right, to show that the angle of ABC is 90 degrees, we need to show that the lines are perpendicular to each other. So firstly, we find the gradient of AB, which is 8 minus 4 over 9 minus 1, and the value is half. Next, we find the gradient of BC, which is 12 minus 8 over 7 minus 9, and the value is -2. From here, we multiply the gradients together, so MAB times MBC equals half times -2, we get -1. Hence, from here, we can make a conclusion that line AB is perpendicular to line BC. Therefore, angle ABC is 90 degrees. 2. From part 1, the triangle ABC is a right angle triangle with angle ABC is 90 degrees. So, by the right angle in a semicircle property, A, B, and C lie on a circle with diameter AC, as AC is the hypotenuse. Part 3. In order to form the equation of the circle, we need two information, which is the length of the radius R and the coordinates of the center O. So to get the length of the radius R, it is half of the length of AC because AC is the diameter. So for this case, it will be square root of 7 minus 2 square, 7 minus 1 square plus 12 minus 4 square divided by 2, which will give us 5. Next, to find the coordinates of center of circle, which is O, it is the midpoint of AC. So it will be 1 plus 7 over 2 and 4 plus 12 over 2, which gives us 4 eighths. Now we know the length of the radius and the coordinates of the center of the circle. Then we can form the equation of the circle, which is x minus 4 square plus y minus 8 square equals 5 square. And it is x minus 4 square plus y minus 8 square equals 25. Part 4. Given the coordinates of B is 9, 8, and the coordinates of the center of the circle is 4 eighths. From here, we can observe that the BO is a horizontal line, which means that the gradient of BO equals 0. Then, the gradient of the tangent at B is undefined as it is perpendicular with the line BO. So this shows that tangent at B is a vertical line, and hence tangent at B is parallel to the y-axis. Part 5. To find the equation of the tangent to the circle at C, first we need to find the gradient, which is 12 minus 8 over 7 minus 4. So this is the gradient of CO. Okay, and we get the value is 4, 3. Hence, the gradient of the tangent is -3/4 as they are perpendicular to each other. So, the equation of the tangent is y minus 12 equals negative 3 over 4 times x minus 7. We expand the bracket, y minus 12 equals negative 3 over 4x plus 21 over 4. Then we make y the subject, it will be y equals negative 3 over 4x plus 69 over 4. We multiply 4 for both sides, then we get 4y equals negative 3x plus 69. And this is the equation of the tangent. Alright, that's the end of the paper, and that's all for this video. Thanks for watching. Do you have any question or doubts to ask? Feel free to write it down in the comments. I would love to hear from you. Do you like this video? Please don't forget to like it and share it. Until then, I will see you in the next video. Have a great day ahead.